composite functions. So the composition of function f with g is denoted with this, and that's like f of g of x is equal to the f of g of x. So this is just some notation. We usually write it in working format over here. X is in the domain of g, and g of x is in the domain of f. Alright, so let's see what that means. If I write this first one into working notation, it's going to be f of g of x. Okay, and that's just from up here. I'm just taking this notation and rewriting it in this format. And the first thing we want to do is we want to plug in what we know. We want to plug in g of x. That's given to me. It's given to me right here. So I'm just going to leave this alone and plug in that g of x. X squared minus 2x plus 6. Okay, my next step, it says evaluate the function. So basically it says go to your f function, write it down. Everywhere there's an x in that, you're going to plug in this for it. So let's kind of follow the directions. Go to your f function and write it down. So let me go to f of x and write it down. Everywhere there is an x, put a parenthesis. Okay? And then now what we want to do is evaluate it at this. So we're go to your f function, write it down. Everywhere there's an x, you're going to plug this in place of it. So now we're going to plug that value in. And then we distribute and solve that out. So 3x squared minus 6x plus 18 minus 4. 3x squared minus 6x plus 14. Okay, they didn't ask us for the domain, but we know it would be what? Negative infinity to positive infinity because it's a polynomial. Alright, the next part says, tell us what the g of f of x is. And so afterwards, my question to you is going to be, are these two equal to one another? Let's find out. Writing in it in working format would be g of f of x. And let's plug in what we know. Let's go plug in our f of x. We're going to leave everything else alone. So I'm going to leave this alone, and I'm going to bring it down, and I'm going to plug in f of x. So come into my given, and f of x is 3x minus 4. Okay. At this point, it says go to your g function, write it down. Everywhere there's an x, we're going to plug this in place of it. So let's go to our g function, which is given to me up here. Everywhere there's an x, actually I need more room. Everywhere there's an x, put a parenthesis. So x squared minus 2x plus 6. So go to your g function. Everywhere you have an x, we're going to put a parenthesis because we're plugging this in for it. So we're going to plug in 3x minus 4. Okay, as a side note, when we're calculating this, we have to go off to the side and do 3x minus 4 times 3x minus 4 and actually FOIL that out. Okay, so we take this off to the side, and this is my scratch work. You FOIL it out, and then this is what this simplifies to. 9x squared minus 24x plus 16. Now we pick back up over here because we've got to continue this. So I want to distribute this negative 2, so that's minus 6x plus 8 plus 6, and then add all those like terms. When we add all those like terms, we get 9x squared minus 30x plus 30. Let's double check that. That will give us a negative 30x and then 6 plus 22. Yes, okay. 9x squared minus 30x plus 30. Part C is the g of f of 1, where in the previous one we had x here. This time we know what x equals. We know x is equal to 1. So we actually went through the heartache of evaluating the g of f of x in the previous problem. So we have two ways we can work that. We can take our solution from the previous problem, which was 9x squared minus 30x plus 30, and evaluate that at x equals 1. So everywhere there's an x, we're going to put a 1. And that would give us 1 squared is 1 times 9 minus 30 plus 30. And we would get the solution of 9. Or let me see if we can go back a page when x is equal to 1. So we're looking at the g of f of 1. The other way you can work this without computing the g of f of x first is to come into your function and it says go to your f. So this is your g of f of 1. This is what we're looking at. If I write this in working notation. So our first thing is go to the f and plug in 1. Go to the f and everywhere there's an x, plug in 1. Go to the f function. So this would be just 3 minus 4 is negative 1. And then I would continue down, just drop this. This tells us to go to the g function and everywhere there's an x, plug in negative 1. So everywhere there's an x, I'm going to put a parenthesis so I can go back and plug in negative 1. And this would be negative 1 squared is positive 1, positive 2. And then you add those up and you can see that we got the same solution either way. The only thing you have to be careful about this first one is because if you made a mistake doing this, it's going to make you have a mistake in your substitutions there. Okay, you don't see this very often, but this time we're given f of g of x. This is the solution. And they are asking us to kind of work backwards and determine, well, what was the f of x and what was the g of x, such that when we took the composition of these two, this particular composition, this is the solution. Okay, in this particular case, we're going to be plugging the g of x into this function. So I want you to think about that for a minute. We're going to be plugging this into here. So when we see this, this is correct. This is this g of x function right here plugged into f of x. So basically, when I take this and plug it in for x, it gives us our composition. So let's try B. It'll give you a few minutes. So we want to know what is the f of x. Now that you have the idea, try this next one on your own. We want to know what needs to be plugged into what function to give us this composition of functions. So the g of x is going to be 7x minus 1. So what is the f of x? Absolute value of x, because then we know when we take this and plug it in there, we will get this. And that's the conclusion of our lesson.